HDLC is a basic. This is a basic data link control protocol. Okay, when I say it's basic, it's the very first protocol that people use a lot. There will be many other protocols right now, and when you graduate, you will study, newer protocol, okay? And another 5 years, they will change the protocol sometimes, okay? Another 10 years. So they all will be outdated, but the concept remain the same, okay? However, the detail of which bit will be what, okay? They will be different. So we cannot teach you what protocol that you will see. You have to go and then you have to read the manual, but we will teach you the idea of why they design the protocol like that. So when you look at it, you know, oh, they do it because of this, okay? And also the techniques of how to differentiate between this field and another field, something like that, okay? So you will see intentional. So this is an example. Okay, and as I told you, when you graduate, when you go to work, you probably will not use HDLC. You will use the newer one, which is maybe a little bit more complicated, but they will have some basic idea. Okay, so you just have to read the manual of whatever you want to use at that time. Okay, so the basic characteristic. Okay, as I say that this one is old. I'm on with. This one is old. So in the past we have three kinds of stations. We have three kinds of station type. Okay, in the past we have like a server, which is like expensive server. Okay, and we have a small terminal, which is cheaper, much cheaper. Have you seen that structure before? One big server, mainframe or something, big server, and then small terminals for everyone else. So we will have a primary station, and they have many secondary stations. But right now, people will use kind of the combined station, right? Because every PC or every tablet, they are equal. So they can be, they are like the same, they can do the same function, okay? So, and it's about the same price, So right now, we usually will use the combined station and not the primary and the secondary station, okay? But this comes from in the past. Let's look at the link configuration. Again, in the past, since we have server and we have terminal, so we have an unbalanced link, or we can have a balanced link. But right now, usually it's going to be balanced link, okay? Because they are like equal in terms of the station, okay? They can be primary and second. They can be both primary and secondary station to be transmit or receive, okay? And how about the data transfer modes? Again, there used to be three modes, okay? The normal response mode, or the asynchronous balance mode, or synchronous response mode. And maybe we'll look at this one, asynchronous balance mode, which is two combined station, okay? I told you before that in data communications, we have a lot of abbreviations, right? And also, when you change the protocol, or you change, use different layers, stuff like that, you have different names to call the same thing, okay? So this one is the abbreviation that you should at least look at it, okay? And get a sense of what it is. And in the exam, I will give you like a small page of paper that you can note down some of the abbreviation, okay? But not to write out everything, just very small page, okay? On something that should not be remembered, okay? But should just be looked at. If we look at the frame structure of the HDLC, if you start with a flag, okay? Do you know what is a flag? Do you know a flag? A flag is like, Thailand flag or signal flag, okay? In the railway station, when you the train comes, right? And there will be someone who like, if suppose this is a flag, and there will be, oh, you can go, okay, or you cannot go, you know, in a, have you played in the, when you were young? There will be a flag here, okay, you can go or you cannot go, and then the train come at the station, okay, that they don't have the signal light, they use a flag as a signal, okay. So the flag is to signal the beginning of the frame, okay. So when you see a flag, you know that the frame start now. We will use an example to explain to you. So suppose we have okay, suppose you receive this, okay? You are a receiver, and remember that we have the 7 layers OSI model, right? So in the data link layer, we receive in terms of from the physical layer, we will receive in terms of binary sequence, okay? Now, the flag look like this. For HDLC, 0, 1, 1, 1, 1, 1, 1, 0. This is my flag. Okay, so can I get a volunteer to mark the beginning of the frame for me, please? Volunteer, volunteer. No volunteer? No volunteer? I'm on with. Okay, so where is the beginning of the frame? Dot, dot, dot is like many bit in between. Okay. Yeah, you can mark that, and can you put a box? Very good. Okay, thank you very much. Yeah. Do you want to do more? You can volunteer next time. So this is a flag. So you got a long sequence, right? But how do you know? Because they don't have a package, right? They don't have, you know, a paper wrap or a box. Okay? So you receive a long sequence of bits. And the receiver knows that this is the start of the frame by finding the flag. So this is the start of a frame. Okay? The next field is address. Address can be 8 bits or 16 bits. Now the address, the first bit of the address, okay, can be 0 or 1. If the first bit of the address is 0, okay, it means that this is not the last byte of the address. Because the address says that it can be extendable, right? It can be 8 bits or 16, or it can be like 1 byte, 2 byte, 3 byte, 4 byte, 6, you know, 4, 5, 6 byte, okay? So how do you know how long it will be? You look at the first bit. If the first bit is 0, it indicates that this is not the last byte of the address. But if the first bit is 1, then you know that this is the last byte of the address, okay? And the next 7 bits that come, that is the actual address value. So please mark, what's this? What's his name? No. พงษ์ปรมัตถ์ Mark the address for me please keep alert address one more to help him okay you will draw it she will help you okay not she will draw it you have to draw it then he will remember for the whole semester that this is the address and everyone else do you know where is the start of the address and the end of the address field okay so thank you so this is the this is the address the address consists of 2 bytes in this case okay again it can be 1 byte or 2 byte or 3 byte depend on look at this this is not the last byte because it starts with 0 when you okay so when you go to this okay this tell you that this is the last byte of address because it starts with a 1 so it will be like 1 byte is 8 bit right so this one this is the last byte so the address end here all right if you want 3 bytes of the address it will be start with 0 and then 0 again and then the next byte will be 1 okay she understand right okay and what is the values of the address the value of the address is actually this part and this part okay 1001110 and then 0100011 okay so the first bit is not the values of the address okay is to specify whether this is the last byte of the address or not to tell you that okay this is the end of the address field the next field is control field okay this may be okay let me change a little bit because let me change to this one okay for the control field is the field that will specify what kind of frames that you are sending in this protocol okay so now you see okay what I'm trying to tell you is that you can have a flag as to signal the beginning of the frame you can use 1 bit to tell you the length of the field okay so this is the technique that you may find in other protocols too okay in some protocol they will tell you okay if we have a fixed size of 3 bytes address we have a fixed size of 8 byte address but in some protocol you just use the first bit to tell you okay how long the address is okay so anyway the next field is control the control has the frame in HDLC there are three types of frames the first one is information frames the information frame you start with 0 if you look at your slide the information frame will start with 0 the supervisory frame will start with 1 0 and the unnumbered frame will start with 1 1 okay so now we look at here look over here this start with 0 so this is an information frame okay so this tell us that I frame okay what we are sending is an I frame now how about the next 3 bits the next 3 bits tell you the sense sequence number. NS equal to 0. Okay. Let me change it to make it more interesting. Okay. NS is equal to 2. Okay. NS is equal to 2. Let me change this one. Okay. NX is equal to 2, which means that you are sending frame number 2. So this is like frame. Suppose this is a frame of A. So A is sending frame number 2. Okay. So this is a sense sequence number. Remember from our space-time diagram, so A is sending frame number 2 to B. So this tells you the number 2. Okay. This bit is pole and final, which we will skip for now. You will come back later. I will show you in an example, which will be easier to understand. And then the last 3 bits of this byte, this is the receive sequence number. This is equal to 1. Okay. So the control field now have 8 bits. It can have 8 bits or 16 bits. In this case, it have 8 bits. The 8 bits, okay, the first bit tell you what kind of frame it is. If it starts with 0, it's I frame. If it is 1, 0, it's S frame, supervisory frame. If it's 1, 1, it's U frame, the unnumbered frame. Okay, and then the next 3 bits. Okay, if it's a U, if it's 0, it's an I frame. The next 3 bits tell you the sense sequence number. Okay, so A is sending frame number 2. You read from the binary values. Okay, then you skip. Okay, and we skip the pole final bit. This is a pole final bit which we skip now. Okay, and we look at these 3 bits. The next 3 bits after pole final is the receive sequence number. This is equal to acknowledge, ACK1. This is the same as okay. Send sequence, receive sequence number 1, okay, is that A sends ACK1. So in the same frame that you are sending now, you send frame number 2 and also you piggyback ACK1, okay? Which means that you tell B that you have received frame number 0 from B correctly and you are expecting frame number 1 from B. So this is what you acknowledge. You add the frame that you got from B. Okay? But this is the number that of the frame that you are sending to B. You are sending to the destination. A is sending to B. Okay? So A send frame number 2. However, it's also piggyback the acknowledgement of the frame that it have received from B. Okay? So it got, this means that it got frame number 0 from B correctly already. Okay. So this is a control field. Now the next field is the information. Okay, information is variable, which means it can have any length. Usually it's in multiple of bytes. Okay. So since it's variable, you don't know when it's gonna end, right? You don't know when it's gonna end. So can I get Kanyapat to find me the end of the frame, please? The end of the frames, if you look at this, you can see that it will end with a flag, right? please. Mark the flag at the end. Okay, and then mark this is end of a frame. No, this one, this bit is the end of the frame, right? Yeah. Okay, thank you. Okay, so even though the information is variable, okay, you can still know the end of the frame by finding another flag. Okay, now then we have before the flag. So what is the beginning? Which bit is the beginning of the FCS? Okay, the frame check sequence, because we have information field, and then it's then we have the frame check sequence, right? And then the flag. So the frame check sequence is fixed. Okay, it can be either 16 or 32 bits in this protocol. So if you decide, at first you have to agree, you know, both sides, that I'm using 16 bit for this communication. So you know, so you count 16 bit from here, from the back. Okay, suppose this is 16 bits from the back. Okay, suppose 16 bit. Frame check sequence. The frame check sequence is the same as your parity check bits, okay? Or the same as the CRC, cyclic redundancy check, they are the same. Okay, but frame check sequence is what they use in this protocol, okay? The CRC is a more common name, and the parity check bits are like a general name for the bit that you add, okay, to get the error correcting code. Okay, so anyway, so this is can be FCS or CRC or the parity check, okay? So the rest is information field, right? So if you are the receiver, you receive this, and you want to know what A want to send to you to process to the next level. This is your information that you will use that will go to the next level. Okay, this is the information field that the A want to send to you. Okay, the others are not the information, but they are necessary in order so that you can the data can be transmitted correctly. Okay, because for example, the FCS, we put it here so that we can check whether the whole thing is correct or not, right? If there's something wrong, you divide the receive sequence with the generator polynomial and it's not equal to 0, then you know that it's not a code word, right? And you may have to correct it, or you may have to ask for a retransmission. Okay, so this is the data. Now, there is one problem that since the flag look like this, okay, and information can be anything. What happens if I have the information look like this? So information will look like a flag, right? So we will have a problem? Yes, because you will not know that this is a real flag or not a real flag, okay? So how do you do to solve this, okay? We can use what we call bit stuffing. The details is in the sheet, and please read the sheet carefully after this also, so that you can get all of what I'm trying to tell you. The bit stuffing, okay? Bit stuffing says, okay, to avoid having the same pattern as a flag, when you have 5 ones consecutively, you will always add a 0. Every time you have 5, 1, 1, 2, 3, 4, 5, you will add a 0 here. so that to prevent it to become looking like a flag, okay? And this is not data, this is called bit stuffing, okay? Not data, okay? It's not the data. It's added here so that, okay, you have also another examples here that you add zeros, okay, after every 5 ones. At the receiver, what do you do? Because you know that transmitter always add, please help me, always add 0 after 5 ones, right? So receiver just take it out, right? But when the receiver saw this, okay, every 5 ones, so receiver actually see this. Receiver will see this, right? Receiver see this. So receiver will just take this away, okay? This is not the data. So every time they see 5 1, they will take the 0. After that, take it away. At the receiver, receiver take it away or delete it. Because it know that this is not the data, it's just added so that you will not get confused, right? If not, Kanyapat cannot find the real flag, right? Because you found there's something inside of the information field that look like a flag, so you can get confused, okay? But if you have bit stuffing, then no problem, okay? So this is one way to prevent. Okay, and there's also the weak point, the good point. Please read more in the sheet. Now for the address, we have, okay, I think you know this already, but there is an additional information is that if you want to broadcast to every station, you will send this one and all 1, 8 bits all ones. If you want to send the data to all stations, the address field will be 11111111, okay? So 8 bits all ones, okay? Which means that every station will receive it. So it's in the mode of broadcasting. Now for the control field, as I told you before, have I frame, S frame, and the U frame. And we have covered the I frame already. Okay, we covered the I frame already. But one thing is that the control field in this case is 8 bit. This is 8-bit control field, okay? We can also have 16-bit control field because sometimes, you know, the 3 bits, you use send sequence number, okay? Only 3 bits. The window size for go back end is how much? 3 bits. Window size is no more than 7, right? 7 is maximum. So if you want to have a bigger window size, okay, because you cannot get a continuous transmission back by the 7 frames, okay? Maybe you remember the continuous transmission, suppose you get it back at like 50 frames, okay? And you want to keep sending as a continuous transmission that we talked about last time. So we have to use a longer sequence numbering, right? So there are another option, use 7-bit sequence numbering, okay? So that is another option. You can use 7 bits for the sequence numbering. So instead of using 3 bits here, so instead of using 1 byte, you use 2 bytes, okay? So you have the 0 as to indicate the information field, and then 7 bits send sequence number, the pole and final bit, and then 7 bits receive sequence number. So now you extend the window size much bigger, right? So 2 to the 7 minus 1, right? So 127 frames, okay? And for the selective repeat, it will be 2 to the 6, right? Now for the supervisory frame, so we're done with the information frame. Now for the supervisory frame, we also have 2 options. We have the 8 bits and the 16 bit. For the 8 bits, okay, we start with 1 0, as I told you before. And then following by the 2 bits of the S, okay? The 2 bits, that's the 2 bits here, okay? I have a table. It can be, I have a list here. Okay. For the 2S bit, okay? If it's 0, 0, it's receive ready. If it is 0, 1, it's reject. Reject means that we are using go back end right now. Okay? If it's 1, 0, it's INR receive not ready. If it's 1, 1, it's selective reject, which means that we are using selective reject right now. So HDLC, we can, it's allow us to use go back end or selective reject. Okay? We can choose by selecting the values in that 2 bits of the S in the supervisory frame. And we also have the NR, because when you say receive ready, you have to tell the number, right? So receive ready number 4, receive ready number 5, something like that. So it's like Act 5, Act 4. Now suppose this is not an iframe, okay? This is not this is a supervisory frame, okay? Can you write down for me? We want to send reject number 3, okay? Please write the control field for me. Anyone volunteering? Anyone? Arya, you want to write? No? Do you want to try? Who want to try? Oh, I think you want to try. You move your hand somewhere. You can come out. Yeah. What's your name again? I'm sorry. Yeah. What's your name again? Narawit. I should not forget because my daughter has a friend named Narawit. Narawit, please write selective reject number 3 here. So, yeah, selective reject 3. So start with, in the control field, start with what? Supervisory. Start with?
1, 2.
Yes. Okay. Whole final is 0.
Retreat.
Sorry. Okay.
Retreat.
1, 0, 0, 1, 0. Okay, 3. Okay, that's it. Thank you. That's correct, okay? The first 2 bits, okay, tell me that this is S frame. These 2 bits tell me that it is a reject. These 3 bits tell me that it's reject number 3, okay? So, you want to try selective reject? Anyone else? In the back, in the back. What's your name? Who want to try? Those 3 in the back, you have to come. One of you have to come, or 2 of you, you can come. You come together, okay? 2 of you, please come together. Now write the control field, okay? For selective reject number 5. Please, quickly, please. That's okay, just 2 first, you can come next time. Okay. Okay, use this pen. Okay, why she is discussing? They are discussing. The next kind of frame is called unnumbered frame. The unnumbered frame is a frame that is not used to send information, and it's not used to send acknowledgement on the frame that you received. Okay, because I frame used to send information, right? And S frame you use to send the acknowledgement, right? So U frame used for everything else. Okay, for example, for the initialization, for the disconnection, okay, of the connection, okay. So we do the mode setting, initialization, disconnection, okay. The profile again, I will use it. I will show you in an example. One zero one one. Yeah, that's correct. Thank you. See, you can do it. Okay. So this is the control field or selective reject number 5. This tell me this is S frame. This tell me selective reject. This tell me number 5. Okay, so it's not difficult. Now I can combine. Okay, if I want to make it more difficult, okay, I can combine it with the chapter 4, data encoding. Okay, so I can ask you to find me, for example, to draw me the control field with binary bipolar AMI or Manchester, you know. So instead of giving me the binary like this, you have to draw me the waveform. Okay, so that will be combined with the physical layer. Okay, so every chapter they are actually connected. Okay, can you see? So this can be combined with the, or sending with the PSK, FSK, something like that. Okay, but the data has to come from like this, S frame. I will tell you, reject number 3. Okay, draw the control field of reject number 3 of the HDLC, but draw it in a waveform. We are sending with frequency shift keying. Something like that, okay? Now, we will look at examples on the operation, okay? We have 3 phases of the operation for communications, okay? We have initialization, and then we will transfer the data, and then we will we will disconnect, okay? Like you try to dial your friends, okay? You call your friend on the phone. So you have a dialing, like make a connection, initialization, okay? Then you talk, make a conversation, that is data transfer, and you disconnect, you hang up, it's disconnection. Okay. So in the initialization, you can request, okay? You will set normal response mode or set asynchronous, this one. I showed you before. You will have normal response mode, right? So this one will be set normal response mode. This is a command. And this command is in the U frame because it's not S and it's not I. So it has to be U frame, right? So any side can set normal response mode to ask for, to initialize the connection, okay? Then you will specify whether you use 3-bit or 7-bit sequence numbering, something like that. Now, if the other side want to communicate with you, okay, to accept your call, then in the phone you will have like the green one, right? The green one with the hanger, telephone hanger picture, and then you slide, okay, with the green one. So it means that you accept the call. So this one, the other side, that suppose A set normal response mode to initialize the call, okay, to B. B have to reply with a unnumbered acknowledged frame, okay. It's going to be something that is like accepting the call. So it's going to be called UA frame, okay. This is also a number frame, a number frame. And then when you finish with the data transfer, finish with the conversation, then usually you will hang up, right, using the red one in your phone, right? The red with the hanger, telephone hanger, okay? Like you hang up. This one, it will send disconnected mode, DM frame. So the one that, if you don't want to accept the call, you will hang up, right? Someone calling you, and then you just slide on the red, you know, on the red one. So it's like you hanging up, you don't accept the call. So if you don't want to accept the call, you will send DM, disconnected mode, frame back, okay? So it's not, the call is not complete. But if you have finished suppose you accept the call and you transfer the data already, and you want to hang up to finish to disconnect, okay? You will send something that is called a disconnect frame, okay? If you want to, after you make a conversation, it's like you hang up after you make a conversation. Now look at the example. I will turn off the light now because I will use the slide as a main, the main board right now, okay? So we have, the first example is the link setup and disconnect. Suppose you have A and B, right? This is the same as the space-time diagram, but you flip it. Another side, okay? Usually we draw it in a horizontal way, right? We have, I deleted it already, that we have A and B, and A sent to B, like this, and B send acknowledgement back to A, like that. But now we move it, we kind of rotate it, okay? So that is in the vertical side, okay? And we do not draw the frame, okay? We just draw the arrows to make it easier to understand the process, okay? However, this one, you cannot use it to analyze like the time very well as the horizontal one, okay? Because if that one you draw the T total, you have the T weight, and you can find the efficiency. Don't forget that last time I tell you how to find efficiency when you have to send, remember, stop and wait, ARQ. If you have, usually on average you have 10, for every 10 frames that you're sending successfully, usually you have to send like 11 times. Remember? And if the frame is damaged, what is the efficiency? And if the frame is lost, what is the efficiency? Remember? Okay, so please think about that. Okay, so this one is set asynchronous balance mode to B, and B send nothing back for a while, okay? A is wait and wait and wait. Wait is waiting and nothing come back until time out. So A resend the set asynchronous balance mode again to B. Okay. Now B receive it correctly and B want to accept the call, so B send UA. Okay, and number acknowledgement. So the call is connect now. Okay, so now both sides can send the data. So they can send the iframes here, and after finishing, they send this connection. So A want to disconnect, A send this connection. B send a number acknowledgement to accept the disconnection. Okay, so that's finished. Okay, and the dot here is actually like this thing inside the dot. Okay, this is a data transfer. Suppose you have another, look at the dot. Suppose it's here. The first alphabet is I, which is I frame. But the number here is number 1, okay? The font is look very similar, but actually the first one is alphabet I, big I, but the next two is the number. Nah? They are the numbers, okay? Okay, so this one, suppose A starts sending by sending an I frame. Send frame number 0. So this is frame number 0 of A. Okay, send to B. And since B haven't sent anything to A yet, this is the start of the conversation. Okay, A has to act 0, right? It haven't received anything yet, so it acts 0. So this one will be I, 0, 0, which means the send sequence number, sending frame number 0 from A to B and act 0. Okay, this is acknowledge the frame that B have sent to A, okay, which is nothing yet. Now, when B receive this, B will send, since B also have information to send, okay, both sides have something to say. Okay, so please have something to say. We become two-way communications and not one way. So this one is I, and frame number 0. Since this one acts 0, which means that want to get frame number 0 from B, right? So B send frame number 0. It's very easy. This is act 0, this send 0. Okay, so send sequence number, this is frame B to A, number 0, okay? And act what? It have received numbers 0 from A to B correctly, so it have to act 1, expecting number 1. Okay. Now A send I, it have sent, okay, it have sent number 0 already, so it's send number 1, right? Because this one also act 1, which means that it can send number 1. Okay. And is act 1 here, act 1 here is correspond to this one, is to this 0. Receive number 0 from B correctly and want to get number 1. Okay, please pay attention so that you can get in class and you don't have to read it. But actually this part are in the books, in the textbook. Okay, they have description and you can read it more. So this part, and so send frame 1, frame 2. Okay, it doesn't have to wait because when you use sliding window flow control, you can you have window size, right? So you can send 1 and 2, and then so this is an accumulative acknowledgment. So it send I frame and frame number 1 from B to A, and then it's act 3, which means that it's act everything up to frame number 2. Okay, so it's cumulative acknowledgement. And then this one. So this one send frame number 3 and then act number 2, okay? If A has nothing to send now, it will send RR4, which is a supervisory frame. It have nothing, no information to send, but it have to acknowledge what B sent to A, okay? Now, in the old exam, okay, I used to give you, you know, in the old exam, I used to give exam like this, blank, 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 blank. Okay, so you have to put in, for example, the number, or you have to put in like or something, or I mean, there will be like some blank in here that you have to fill in. So you have to understand the process of what is going on. Okay, at this step, what it should be, and it's, you know, sometimes there are many blanks, right? So there are a lot of scores. So if you miss one, maybe you miss the whole thing. So be careful, right? I mean, doesn't mean that it's gonna be in this exam, but it's just that it used to be an old exam question, okay? And I can also ask you, what does this mean? What is I13 mean? Okay, I can ask you that. Okay, the next scenario, this is BC condition. BC conditions means that you one side is BC, okay? Like in this side, which side is BC? Please look at the space-time diagram. Which side is BC right now? A or B? Who think A is BC? Okay. Who think B is BC? Are you raising your hand? Who think B is BC? It's not obvious, okay? It's not obvious. A is BC right now, okay? And now let's look at this, okay? Suppose this is, we cut, you know, in the middle of the transferring of the data. So, okay, right now B is sending number 3. I frame number 3, X0, okay? So B is sending. Now A receive 1 I30. So it's received frame number 3 correctly, but it's not ready to receive frame number 4. So what do they do? What will you do? It will send, what is this? Huh? Receive not ready, number 4, which means that I have received everything correctly up to frame number 3, but I'm not ready to receive frame number 4. Okay. So B is waiting. Okay, suppose this is a long wait. Okay. And then, why is not finished yet? What are they doing? You know, they want to, you know, to know what A is doing. Why it's not finished yet? So B sent RR0 pole. What is RR0 pole? Okay. Now let's look at this. RR0 pole, we say that the control, okay? the control, we have a pole final bit. Okay, let me delete this and we will. We have a pole final bit, right? So this is supervisory frame, and we have R and R4. So R and R is what? R and R is 1 0, maybe? Yeah, 1 0. Okay. So 1 0, pole, and then 4, right? Okay. This tells me that it's a supervisory frame. This tells me that this is R and R. Oh, sorry. No. This is not the other one. This is RR0. This is RR0 pole. RR0 pole is this. RR0 pole. Not the R and R. This tells me that this is RR. This tells me that is act number 1, right? RR number 1. RR number 1. Sorry. RR number 0, okay? But this one tells me that this is called a pole final bit. If it's sent for the first time, it is a pole. It's called this bit a pole. It's like polling. Polling is like asking. You know, when they make a poll, asking what do you have opinion on the prime minister, something, okay? They have some polling, okay? So this is polling. So P is set to 1, okay? If this bit is set to 1, it means that the sender, okay, who set P to 1, want to demand an answer from the other side. So when it send this frame, okay, with the control field with P equal to 1, then the other side have to answer, okay? Answer on the status of the other side. And when they answer, they will set this bit to be 1, okay? And it will call the answer final. So this B sent to A, B sent to A, okay? RR1 pole, this is equal to RR0 pole, okay? Now A has to reply to B, right? A has to reply to B. A want to reply to B. If it's still not ready, okay? You keep bugging me, I'm not ready, okay? R and R. Again, I'm not ready. R and R. Number R and R4 final. I'm still not ready, okay? So what is the frame here? 1 0 to tell that it's a S frame. R and R is 1 0 again. Then this is final bit. This is to tell you the status. Tell you that this is the answer of the poll. That this frame we are sending as the answer of the poll. 1 0 0. This is okay. This tell you that this is S frame. This tell us that it's R and R number 4, and this tells that this is the answer of what you are asking. Okay, it's the answer of what you are asking. Okay. So we go back to this. Okay. So next we have so after B asks, okay, B is waiting, okay, not ready. So want to ask. So A answer still not ready. Okay, and this is the answer. So it's set final to 1. So it wait for a little while. I want to send the information. I cannot wait anymore. Ask again, right? Ask again. RR0 poll. So they can keep asking, right? Asking for the status. This is an S frame, okay? This one, oh, okay, I can be ready. Keep asking many times, right? Keep bugging me. Okay, RR for final, which means that, okay, I'm ready to receive number 4. Okay, this is your answer. Okay, now, oh, this one is happy, right? RR4, so I can send I frame number 4. Okay, and act what? Act 0, because it haven't received any frame from A yet, right? This still act 0. Any questions on this? We can combine many scenarios together, yes? Okay. Where? Oh, everything? Okay, the PF. P is just to ask, like I'm asking you, what color do you like? Okay, so I'm asking, I ask the other side. So this, like, polling is like asking the question. So this one, I ask the status. When they said P to 1, it means that I want to know your status. Okay, so they said 0P, because this one sent received not ready for, right? But B has data to transmit. And they wait for a little bit. This one still not say that it's ready. So I want to ask, okay, maybe it's faster, like you keep bugging another. Are you ready? Are you done? Something like that. Okay. So they say, okay. So they said 0 poll to ask that, what is your status? So this one answer still not ready, right? And they have to set that bit to final. The final to be, it's the same bit. But if it's a question, it say that it's a call poll. But if the answer is called final, okay? It's the name in the protocol, the name of the bit in the protocol. So this one is still not ready, so B cannot do anything, right? I mean, we cannot send data. B cannot send data because it's not ready. Then, so afterwards, ask again. So when this one say that they are ready, A is ready to receive data, then B can transmit data. Okay? Any questions? Please study this. It's not difficult, but if you miss something, the whole thing will be gone because it will kind of accumulate the errors, okay? So make sure that you know it. Now the next one is recheck recovery, okay? This is the go back in ARQ. This case, A sent to B like this, and then A sent number 3, frame number 3, then A sent frame number 4, but frame number 4 is lost. Okay, it doesn't arrive at the B, okay? And frame number 5 arrived, so it's B received number 3 and number 5, okay? But didn't receive number 4. For after it received number 5, this is the same as what I draw in the space-time diagram in the horizontal. So it's reject number 3. Oh, sorry, reject number 4, right? Number 4 is lost. Reject number 4. So this one has to resend 4, 5, 6, right? 4 and 5 because it has to send 5. So it have to resend number 4, and then it also have to resend number 5, even though it may have received number 5 correctly, because this is go back in. If you use reject, it means that you are choosing go back in. Okay, so 1, 4, 5, and then the next one will be 6. Now I may ask you, okay, if I change my question to selective reject, I put an S here. Selective reject number 4, okay? So what should be here? 1, I40, that is correct, okay? So what is the next one? I60 and I70, okay? So now you know that if I use selective reject here, which means that I choose another technique. I use a selective reject technique, okay? So this one will be 160, I60, sorry. It looks like a 1. I60, okay? This is another case, okay? This is timeout recovery. In this case, A sent 1, 2, 0 to B. So B received number 2, so it's RR3, okay? It's RR3. It has nothing to send to A. You have no information to send to A. RR3, okay? Now, before it get RR3, okay, before A get R3, it have already sent the I30, which is okay, right? Because the window is not run out yet, okay? It can keep sending. So this one, but this one lost. Now it make it confused, right? Because it sent R3, why? So it's waiting for R3, why? I mean, this one is not, may not be confused because B, they know that they have nothing to send, okay? Send this R3 to A, but A send 130 and no acknowledgement, no RR4, you know, no receive ready for back from B. So after a while, why I don't get anything acknowledgement from B? So it may be something happened with this frame, okay? So after timeout, instead of resending the whole frame, now you can see the timeout and the asking status. Maybe the I frame is very big, right? But the supervisory frame is much shorter. So instead of resend the I frame, the whole I frame again, it asks the status first, RR0 poll. Okay, what is your status? This one, RR3 final. This is the answer. Oh, it means that we haven't received number 3. Now I know. Then A will resend the iframe number 3, right? But if we say RR4 final, it means that we have received number 4 correctly. So this one can go to, if it R4, then it have received number 3 correctly. Then A can send number 4, I40. Okay, so they have like other options. So poll is kind of make it sometimes, okay, it's preferable to use to ask the status. Okay, I think this is, so this is timeout recovery. Okay, this is what I know that a lot of questions on the poll and final, so I'm trying to note down, okay, to answer your questions, okay? And also, the description of this are in the textbook because these pictures are in the Stalling textbook, so you can read more from that. And next time we will go to the chapter 7, which is multiplexing. Please read before, okay? Because we are a little bit behind schedule. Thank you very much.